Okay, so it goes here, find the equation of the tangent and the normal for the graph this at x equals pi over 4, all coefficients in exact form. Now, let's just have a look at, first I'm going to write this down, y equals 3 tan x minus 2 root 2 sine x. Now, I just want to put it out there that this, sometimes I like to work in degrees, and this you should know is 180 shared by 4 is 45 degrees. Okay, sometimes you can't put that in as long as you know how you're working with it. In radians it will work too. So I'm now going to just, all I'm going to do is in red, if I just highlight those, not forget about them, but just keep them outside, the constants. If I do dy dx, well, the constant does not change. Now, the differential of tan is, sec squared x, and minus 2 root 2, the differential of sine is cos x, as we all just said. Okay, so the differential of that function is that. Simple. Why do we differentiate that? This gives me the gradient at any point on that curve, which is the gradient of the tangent at that point. So if I want to know the gradient of the tangent at when x is 45 degrees, I'll just say, well, that is the same as 3 over, now sec squared is 1 over cos, so that will be 3 over cos squared, and the degrees is 45 degrees, and minus, and this is 2 root 2 times cos of 45 degrees. Now you should know that 45 degrees is just root 2 over 2, so I'll get 3 over root 2 over 2, but I'm squaring all that, minus 2 root 2 times root 2 over 2, which is cos 45 degrees. So the gradient at that point, if I square that, I'll get 3 over root 2 times root 2 is 2, and 2 times 2 is over 4. And here, minus, this is going to be, root 2 times root 2 is going to just give me 2, but these 2's are going to cancel out there, so I'll just take away 2 there. Now, the best way to deal with this is this 4 underneath is a dodgy bracket, you just bring it right to the top, and that becomes a times. So you get 4 times 3 is 12, half of 12 is 6, take away 2, and that will give me 4. So that tells me that the gradient of the tangent at this point is 4. Now, let's just put that in here. I'm just going to put also semicolon, because if I know that the gradient of the tangent is 4, I can also write down that the gradient of the normal, because you just do the reciprocal of that and then negate it, is going to be minus 1/4. I'm just going to put that out there. Okay. Now, once you've got that, we need to find the gradient of the tangent and the gradient normal. The only thing what we're missing so far is, because you need the gradient with a point. I know that the x coordinate is 45 degrees. I'm going to leave it as pi over 4. I want to know what y is. Well, if I put 45 degrees in there, I'll get y equals 3, well, we all know what tan of 45 is, which is just 1, minus 2 root 2, and sine of 45 is root 2 over 2, same as cos 45. So that's going to equal 3, because 3 times 1 is 3, and that's going to be minus, now root 2 over 2 times that, we just had the same scenario here, root 2 over 2, that ended up just being 2. So y is just going to be 3 take away 2, which is going to give me 1. So this scenario, we know that y is going to equal 1. Okay, we've got those points, and we've got those gradients, and we need to find the equation of those lines. So in the exact form. So first of all, here's my tangent. Now my equation of the tangent is going to be in the form y equals mx plus c. Well, they're both going to be in the form y equals mx plus c. So the tangent, the gradient is 4, so I'm going to have y equals 4x plus c. And this goes through this point. X equals pi over 4 when y equals 1. So if I plug that in, this 1 equals 4 times pi over 4, which is beautiful. The 4's will cancel out. Therefore, c equals, take the pi of there, 1 minus pi equals c. Therefore, the equation of the tangent is y equals 4x plus 1 minus pi. Happy days. Now, if I want the normal, I'm going to do the same thing, but this time I'm going to have y equals minus. So y equals a minus 1/4 x plus c. And again, I'm going to sub in these points. Y equals 1. Now this time, just be careful, that's a quarter pi times a quarter. It's going to be a minus pi over 16 plus c. And therefore c, when I take that to the other side, is going to be 1 plus pi over 16. In which case the equation of the tangent, equation of the normal will be y equals minus 1/4 x, and plus c is plus 1 plus pi over 16. And that is it.